Okay, so one of the examples of curvilinear motion is the projectile motion. Okay, so we all know, okay, so maybe uh, speaking to my students this semester, so alam naman natin na napagdaanan nyo na to during your physics. Okay, so for physics for engineers, so if we consider this figure in which we have y and x component, okay, speaking of 2D, two-dimensional projectile motion, so we all know that we already have acceleration due to gravity, which is g. Okay, so in this case, your g is equivalent to 9.81 meter per second squared or 32.2 feet per second squared. Okay, so meron kang, so let us consider that your x sub o is your initial position in x-axis, and your y sub o is your initial position in y-axis. Okay, respectively. Okay, so at the beginning, meron kang initial velocity or v sub o, in which ma-breakdown natin siya into components, in which meron kang vox and voy. And then, along your projectile motion, ito yung projectile motion mo, at any time, kahit hindi pa siya bumagsak dun sa lupa, for example, makikita natin at any time yung velocity, okay? Yung velocity na hinahanap natin in terms of x and y axis, okay? So let's consider these formulas, okay? So we sum up forces along horizontal, we sum up components along horizontal and vertical. Also, if you remember these formulas, okay, v is equal to vo plus at, okay, all in x component. So we all know that acceleration along x is 0. So we substitute. So we therefore get vx is equal to vox. And then we have x equals x sub o plus vox plus a sub x t squared over 2. So we all know naman na yung acceleration along horizontal is non-existing. Okay? So we therefore get these formulas, okay, respectively. Also for this formula, okay? So from our rectilinear motion, okay, v squared equals vo squared plus 2a times x minus x sub o, okay? Since nasa x component tayo, kaya may sub na x. Okay? So ang matira na lang kasi 0 to, so therefore vx squared equals vox squared. So we get this formula. Okay? So ibig sabihin, along horizontal component, okay, consistent lang yung velocity mo. Okay? Yung initial velocity mo along x component hanggang sa at any point along your projectile, the same lang siya. Okay? Vx is equal to v sub ox. While the only thing that is changing is obviously your position along x-axis, which is your position at any time, which is x is equivalent to x sub o plus your initial velocity at x direction times the time. Okay? Times the time that lapsed from the beginning. Okay? From the your initial position. So, just memorize these formulas if ever nakalimutan nyo. And then for the vertical component, same story, but the difference is that we have a value for a sub y. Okay, we have the value of acceleration along y-axis, which is equivalent to g. Okay, speaking of, v is equal to v plus a times t along all along vertical component. So we get this one. Okay, so we replace a sub y by g. So we get v sub y is equal to voy plus gt. Same with your formula for position along Okay, here is a position along y-axis. We have y is equal to y sub o plus voy t plus a sub y t squared over 2. Since ay is equal to g, so we get this formula. Okay, y sub o plus voy t plus a sub y t squared over 2. And then, we have this formula, okay? V squared equals to VO squared plus 2A times y minus y sub o. All with a subscript of y, okay? So, dahil yung a sub y mo is equivalent to g, okay? So, if naalala nyo to sa rectilinear motion, okay, same lang din yung formula. But somehow, curvilinear na to siya, okay? Applicable lang yung formula, kaya lang may x and y, x and y component tayo dito. Y component, nag-i-exist yung g, ay yung acceleration along y-axis, which is equivalent to g, or the acceleration due to gravity. So, therefore, v squared y is equal to voy squared plus 2g times y minus y sub o, where your v sub y is your velocity anytime along y-axis, along the projectile motion, okay? So these were the important formulas for projectile motion. So I hope you have learned something.